A shrink packaging line can produce one clean-looking door panel and still fail the conditions that matter after installation. Heat, moving conveyors, sealing equipment, electrical controls, and surface-sensitive products create risks that a simple startup demonstration cannot expose. Acceptance, therefore, depends on repeatable evidence, not a single favorable run. Before factory testing begins, the buyer and supplier should agree on the delivered configuration, included conveyors and accessories, representative samples, utility conditions, operating sequence, safety demonstrations, appearance criteria, required documents, and the process for closing nonconformities. Each result should receive a clear status. Pass with a documented condition, retest required, or verification required during site acceptance. The sample set must reflect actual production boundaries. A standard flat door may behave differently from a glazed door, a decorative panel with raised edges, or a wide laminated board. Testing should include the largest, most surface-sensitive, or most complex agreed products within the design envelope. Inspection criteria should address film coverage, seal integrity, loose edges, wrinkles, exposed corners, contact marks, cleanliness, and package condition after cooling and transfer. 6 evidence gates create a disciplined acceptance sequence. The first gate covers safe control, emergency stop response, guarding, accessible isolation information, and controlled restart behavior must be demonstrated. The test should show what motion stops, how heat-related conditions are managed, who can reset the system, and what must be checked before production resumes. The second gate addresses product movement. Detection, entry orientation, conveyor stability, transfer, and unloading should be observed with representative samples. Speed adjustments must be assessed against both stable handling and package quality. A broad adjustment range has little value if the intended operating settings cause movement, poor film presentation, or unreliable discharge. Gates 3 and 4 examine film feed, coverage, sealing, shrinking, pressing, cooling, and final finish. The seal must remain intact through the agreed transfer sequence, and the package should remain orderly after cooling and unloading. Performance that depends on unusually slow operation or repeated operator intervention should be recorded as conditional, not treated as routine capability. The fifth gate concerns maintainability. Access, cleaning, routine checks, consumables, and the path for replacement parts. The sixth confirms handover evidence, including manuals, drawings, settings, test results, responsibilities, and unresolved actions in a controlled file. A 15-unit risk structure supports closure without allowing serious failures to disappear inside an overall score. Critical conditions remain pass or hold decisions. An emergency stop failure, missing required guarding, an unsafe isolation path, or uncontrolled hazardous movement must halt acceptance until correction and redemonstration. High-risk conditions carry 4 units and include unstable transfer, seal failure, loose package edges, and repeated visible surface defects. Moderate issues carry 3 units, covering unclear settings, inconsistent appearance within agreed tolerance, or incomplete operating records. Low-risk items carry 2 units for matters such as labeling or minor documentation issues without operating impact. The remaining 6 units represent controlled evidence across product quality, controls, utilities, maintenance, and handover. Repeated defects require a root cause record. Film type and roll condition, product dimensions and orientation, conveyor speed, tunnel settings, roller position, cooling time, and the point where the defect appeared should all be retained. This allows a retest to isolate the cause instead of changing multiple settings and obscuring the result. Factory evidence must also be separated from site assumptions. Final electrical and pneumatic connections, ventilation, upstream timing, unloading space, and material flow may require site verification. Every open item needs a named owner, target date, required evidence, and a clear statement on whether production can begin before closure. The final decision should leave installation, operations, quality, and maintenance teams with an approved method they can repeat. That is the difference between seeing a machine run and knowing the delivered line is ready to move forward.